Okay, hello everyone, and you are welcome under the sixth session under Unit 1. And we are going to look at steam distillation. At the end of the session, you should be able to use steam distillation to isolate oils from either caraway, cinnamon, cloves, or cumin, right? And you should be able to prepare a derivative of the main components of that oil, right? Now, steam distillation is typically known for the extraction of essential oils. You have the typical setup here, you have the schematic as well. So the steam chamber, your solvent, your sample chamber, and then where your distillate or your essential oil is collected, right? Okay, so your sample that you have, right? The sample you want to extract its essential oil is transferred into your sample flask and then it is boiled vigorously over a period of time to collect your distillate in your receiving vessel. Now, at, at some point, you realize that your distillate will become colorless. So, everything that is being distilled into your receiving vessel will become colorless. It gives you a kind of some kind of idea about whether you are done with the extraction or not. Because if the display becomes colorless, then it means almost all your sample is being what has been collected, or all the essential oils have been extracted from your sample, right? Then you can transfer this distillate into a separatory panel, and then you wash. Of course, you always have to rinse the receiving flask again with some amount of solvent. Now here you're going to use 10 ml ethylene chloride. Now when you are done, you transfer this into your separatory funnel, and then you have to know which layer is the ethylene chloride, because that is where your organic layer will probably go. So you can do this based on density. So you check the density of ethylene chloride and you check the density of your water. Then you compare the two. And this the density, the more dense one, the more dense solvent will be at the bottom, whereas the less dense will be at the top. So you shake the funnel, the separatory funnel, while occasionally venting it to release the pressure. Now you collect the ethylene chloride layer in a small aluminum flask. You repeat the extraction with another 10 ml of the ethylene chloride. Now the purpose of, I think we know of this, the purpose of successive extraction is to make sure that we get more of our essential oil out of the the aqueous medium, right? And afterwards you add sodium sulfate, which is a dry agent, right, to remove the trace of water that may have entered your ethylene chloride layer. You use the weight of the oil. Then you concentrate. You do the final concentration on the rotary evaporator to remove all the ethylene chloride from your sample, and then you weigh the oil, right, to know the percentage yield you were able to obtain. So depending on the amount of the raw material you use, you calculate the amount of oil you were able to extract from your sample. Okay, so in most cases, the essential oils that are being extracted are highly volatile or unstable, and the best way to characterize them is to form derivatives of this unstable or more volatile organic compound. Because when you form the derivatives, then you kind of put them into a more stable state where they can be characterized using the melting point or other techniques, right? So we have a typical example here. You have cuminaldehyde. Now, cuminaldehyde is unstable and very, very volatile. So the best way to characterize this or to put it in a more stable state is to react it with the semicarbazide. Now, the semicarbazide reacting with our cuminaldehyde, then we can form our cuminaldehyde semicarbazine. And this compound is stable and less volatile. So then we can run melting points of this compound, and then we can characterize our essential oil. So mostly that is the best way to characterize them because they are very volatile. Okay, so in order to form the derivative of the essential oil using the semi-carbazone approach, you can prepare your semi-carbazone by adding zero point 0.2 grams of semi-carbazide hydrochloride to 0.3 grams sodium acetate in 2 ml distilled water. So your dissolved or your essential oil is first of all dissolved in 3 ml ethanol, and then transferred into a test tube, and then you add your semi-carbazone, your prepared semi-carbazone, and then this mixture is warmed briefly on a water bath and then allowed to cool to form your crystal. Now, there are cases where you can further recrystallize your derivative using methanol to further purify it before you actually determine the melting point of your essential oil. Now, you can always make references to literature to identify the kind of essential oil you've been able to isolate and characterize.